Um, okay, so today we have a lot of material to cover, but before we start the announcement, we change our groups this week. So those who had labs on Tuesdays now will have recitations on Tuesdays and labs on Thursdays. So maybe it will be confusing this week, but next week I hope you will remember which day is lab and which day is recitation. So, and I don't think we will finish today earlier because we need to. So today we will finish actually the data types in Python. We covered integers and lists, booleans, and so on. So today we will finish the data types. We will cover sets, dictionaries, and user data types, which are the modifications of classes. So we don't cover the classes in this course, but I mean formally, but we will cover some simple cases of classes. So, but before we are going to the remaining data types, I want to introduce, I believe last time I mentioned functions that we can perform on lists: map, filter, and lambda functions. Again, it's not covered in our class, but without these functions, you will maybe write 15 lines of code that you can do in one line. And this will be useful for your this week lab and for the final project. So let's get started. New project. Week 9. So let's recall last time we had a list. And how could we sort the list? Do you remember? There were two methods, one function, one method, sorted and sort. Do you remember which one changed our list, the original list? And we called this operation in-place operation.
The sort.
The sort, yes. So if I print a list dot sort, what it will print? It will print none. Why? It will print none. Because it's an in-place function, and function doesn't return anything. It changes the object in place. And if function doesn't return anything, it returns none. So how to print the list? How to print the sorted list? We should apply this function and then print our original list. Okay, so this is a reminder from last week. So this function, so in Python, everything is class. And today we will talk about classes. Classes have functions and uh, constants, variables. Um, and you can call the attributes of your class using dot. So the string, the class string, has a function sort. And if the function is a function of a class, we call this method. So sometimes I reference to these values as method. Sometimes I reference as attribute. So for example, if you type math.py, it returns you a constant which is stored in class math. And I don't remember, it's 10 or 14 digits of pi. And you can, for example, let's play a little bit around terminal Python import math.py returns a constant. So in this case, I reference to this attribute of a class. If it's a function like sort, I reference as method of a class. So classes have two main, how to say, elements, features, yes, functions and variables. So a function we call method, variables we call attributes. And for example, you can redefine the attribute of class math, like for example, math dot pi equals just 3. And now if you will call math.py, it will be, even though math.py is a built-in library, but you can redefine the variables in this class. Or you can define like as a function math.py. So let's go back to sort. This method, so now I will reference as a method, but it's the same as function sort, has two attributes. Well, has two parameters. One parameter is reverse. And you can guess that it will sort, but in increasing order. Oh, decreasing order. So sometimes you want to sort in the reverse order. The other parameter is key. So this is a little bit more tricky. This parameter takes a function. So, for example, I want to sort my list by evenness of the numbers. So I want to have even numbers first and odd numbers last. So you can write a function, define a function like even function. And this function will just return the remainder of the division by 2 of x remainder. And you can indicate this function as a key parameter here. And because we reference by identifier, by function name, you don't need that parentheses. Okay, so what you see here, uh, can anybody explain what how the sort function worked with my um, user function? Yes.
Basically maps every point on an A list via the function. I'm just guessing. It map every point on A list via the function
Yes.
and then orders the results.
Yeah. So so this yes, you're right. So this function will be applied to each element. So for example, if we apply my function to the first number 1, what it will return, what is the remainder of division by 2? 1. Then it will be applied to the next element. Then to the next element. And so it will go through the entire list, and then the sort will be applied to the new list, to the kind of transformed elements. And because it's because last time we figured out that it applies quicksort. Quicksort uses somehow the pivot element, and that's why the result at least actually is not in order. It depends on how this pivot element was chosen. We choose as the first, but in some implementations, it's a random choice of the pivot element. So, but you can see that the first elements, they all sorted as, wait a second. Uh, why the, like, oh, sorry, for 0, okay, and no, but for 0, the remainder is 0. So the function sorted the list of ones and zeros, and it doesn't distinguish between zeros, because for this list, these are equal numbers. So it just put all the zeros on the first place and then all the ones. But for this function, it doesn't distinguish between two zeros. But the elements behind these zeros, it makes sense for us that they can be also placed in order, but you can see that they are not actually in order. The order of this function is zeros and ones. So this is how the function key, the parameter key works. You can sort your list, but making your list into some other numbers. For example, let's clean all drawings. For example, you can have the negative values, but you want to sort only by absolute values, by the magnitude of numbers. Then you can apply abs of x, and then the absolute value of 0 is the smallest, then absolute value of 1 is the next smallest, then absolute value of 4 is next smallest. So it will be sorted, but according to our function. So next step. Um, let's say you want to sort a list by absolute values, just somewhere in your code. And you will need to write a function just to use this function somewhere in your code once. Maybe it's not very efficient. For this reason, you can write so-called lambda functions. So lambda functions is a function that is not actually created. It will be applied on the fly um, only when we call this sort. So you don't need to create a separate function which returns absolute values or whatever. You can do this here, lambda, which will take absolute value of x. So the syntax is pretty the same as a normal function, but in a line. So you can pass the real function, the normal function, or you can pass the lambda function. Lambda function won't create an object. So I think you've heard about two main paradigms in programming. The first is called um, it's called um, okay. It slipped my mind. So the second is called functional programming. And lambda function is the element of functional programming. But the coding that we did before today, it was all in the like conventional, like another paradigm, which is called huh? Uh, it's not conventional, it's
Procedural?
imperative. Imperative. Yes, thank you. Imperative. Procedural imperative. So when we define everything in functions, so it's one paradigm. When we use our functions as a part of the calculations, then it's called functional programming. So Python, there are languages which work only in one paradigm. For example, C is imperative language. Rust is functional programming language. Python combines both paradigms. So you can use also elements of the functional programming. Okay, so mm, what's next? Map and filter. Two more methods that are very useful for working with lists. Oh, by the way, just one more comment about this lambda function. It can be very useful to sort tuples. In the previous homework, you were provided the code that sorts tuples by the second element, and you remember there was quite long code for that. So with lambda function, you can do this in one line. So that's why I want you to know this before we're going actually to apply sorting lists or dictionaries or user data structures, because instead of writing like adapting the sorting code, you can just use one line of lambda function. So let's say you have tuples and you want to sort them by second element. Um, so how to modify my code if I want to sort this element by the second parameter. So I could use the function, and in the function I would return x of 1, the element with index 1 of x. Or I can do this also in length function and return x of 1. And voila, our list is sorted by the second value. So I hope you will really appreciate this, especially for the final project when you need to sort lists by some fields in your nested dictionaries. Okay, unfortunately, it's not covered in this class, but I decided to spend time and introduce this. Also, map and filter are not the part of this class, but I don't know how to live without these functions. I mean, if you need to pass any context or test on Python, you will definitely have questions on map and filter for lists. So let's talk about these two. Map. So now I don't want to sort. There is a function map. And this function will just apply your function to each element of a list. So for example, I can use this function, even f. So I will create it. I will take back the list. So the result, the result. It, the result will be a list, but after applying this function to each element. And, but you won't see anything if I run this code. You will see just the reference to some memory. So we should cast this into list, and then you will see the output. So, oh, so map. Map is the synonym for function, like real function or real mapping, but map some numbers into other numbers, like x into x squared. So in this case, map applies your function to every element of your list. Again, you could write a for loop and iterate through list and initialize empty list, append elements squared or absolute values, but you can do this just in one line. So this map applies, and again, you can use here lambda function. You can use here, for example, lambda, and let's say you want to sort the strings. Um, but without but case but not case sensitive, like without differentiating uppercase, lowercase. In this case, you can just apply method lower to every element of your list. And this is how it will work. So the last method or function that we can apply to list is called filter. So let's say you want to take all the strings from your list that begins with capital character. I don't know why, but for example, you need to create a new list, but with elements that begins with uppercase. Of course, again, you can do a for loop, but you can apply filter, kind of filter by this condition that a string begins with uppercase character. We can do that. So instead of map, we can use filter. And the condition that the string begins with capital character will be X, the first character is uppercase. So it's one line, but to fit it in on the screen, I used this new line. So let's run this code. And as a result, you will see the list of all the strings that begin with uppercase character. So how it works, it just goes through every element of list and checks the condition. Oh, by the way, for filter, your function should return true or false. For map, your function can return anything. For filter, your function should return the boolean, true or false.
Mine's doing, I have map and it's doing true false.
Yes, you can do also map with true false, but you can do map with, for example, taking lowercase, just casting all the strings to the lowercase. Then you will return x dot lower.
Yeah.
But yes, you can also use for map true false, but in filter, your function should always return true false. It will be the condition on which you decide to keep or not the element in your list. Does that make sense? So that's why it's called filtering, kind of weird. Eliminate the elements, eliminate the entries that don't satisfy our condition. Okay, so that's it for working with strings. And now we can go to the this week topics. What? Yeah, it was introduction. It was out of the scope of this class, but I think it's actually more important than data structures that we will work with maybe for 2 weeks. So sets. Okay, so new data type sets. Not new, we talked about sets. These are kind of the same as lists. You can append elements to the sets, but they keep only unique elements. So for example, if your set contained a number 2 and you will add a number 2, it won't change your set because the number 2 was in your set. So it kind of just a bag of elements, of unique elements. To create a set, like in string, you can type str and brackets. Similarly, you can create set. And set doesn't have all order. It's just a bag of elements. You can't, because it doesn't have order, you can't sort sets. But sets, because they are stored in computer memory, and computers are deterministic machines. They still have some ordering in lower level. I mean, somehow they were stored in the memory, in the computer memory. And this is done using hash function. We will talk about hash functions in 2 weeks. So it's okay. We don't expect you to understand now how this hash functions works, but literally they just map an element into some place in the computer memory. So even though sets are unsorted, but still they have some ordering in the lower level. That's why if you want to check if element ABC is in our set, it will be a constant time operation because by hashing function, it will get the precise place in the computer memory, and it will check if this variable is or constant is in our hash or in our set. What about lists? Let's talk about lists. Do you remember what is the time complexity to check if the element, if the variable is an element in our list? What is the time complexity to check if X is in our list? Okay, maybe. Can we do better?
Sorted. Binary.
Oh, yes, if it's sorted, yes, we can do better even only if it's sorted. Yes, if it's sorted, then we can do a binary search and it will work for local, but in general case, it's all okay. You're right. Yeah. For some reason, I was thinking about local, but it was sorted. So, but because to check if X is an element of our list, we should, in the worst case, we should iterate for the entire list. In case of sets, it will be just constant time. So let's maybe do a short. Actually, we will do an example with sets later. So with sets, you can do operations that you learned maybe when you were talking about sets in math. You can join them, you can intersect them, you can check if an element is element of set. So in Python, the join operation is called union, intersection is intersection, and you also can check if one set is a subset of another set. And now let's solve the problem. And in this problem, we actually will play with set examples. So this is the task. Assume we have a promotion, and let's say there are 10 different coupons in the boxes of cereals, and you will get maybe a ton of cereals if you will collect all 10 coupons. Or maybe it will be another price. So how we can solve this problem using sets? So let's say every coupon has a number, an index, like from 0 to 9. And every time you buy a box, you will find a coupon there, and then you will add this number into your set of coupons. Does it make sense? So for example, I will create a set of coupons, and every time I will open a box, I will append in sets. This operations is called add. Add is in place operation. If you use union, it's not in place operation. Then you will need to write coupons equals coupons union and new element, but you can do that. So, and you will add a new coupon ID number. So, for example, if you will get the coupon with a number in your coupons, it won't be added because sets don't allow repeating elements. And when we will stop this process? So you are buying a box, you find a coupon, you add this coupon to your set. So you buy 100 boxes, you can buy 200 boxes. When you will stop this process? For example, we know that we need to collect 10 coupons, 10 different coupons. We will stop when the length of our set is 10. So we will continue this process while the length of these coupons is smaller than 10 or n. But when we will collect all the coupons, we will actually go out of this while. Does it make sense? So there is a mathematical formula. How many boxes you should buy to collect n coupons? So let's check this formula. We will create random numbers. So it will be our coupons in the boxes. And we will append these numbers in our set. And we will also introduce a counter, how many times we generated a number in other terms, how many boxes did we buy. And we'll compare the counter that we will create and the mathematical formula. So let's create this code. Yes, the next data structure is dictionaries. So new file, coupons. Oh, from random import randint. So we will initialize the empty set. We will initialize a counter. And then we will write a while loop. Oh, we also should introduce the number n. So let's do 10,000. In Python, to make clearer the um, scope, the ah, yeah, the place values like thousands, hundreds. You can use the underscore. So we will append to our set coupons.add a random number, rand int, in range from 0 to n, and we will increase the counter. After that, I will print this counter, but also I will print this mathematical formula. So print counter and this mathematical formula. Just to use log, I should import math.log. Okay, let's run. So the log stands for the natural log base e. If you want to use base 2, you will use log 2. If you need log base 10, you will need use log 10. By default, it's base 2. Oh, actually, did you see? You can indicate base as the second parameter. So, oh, I didn't change the file. Okay, so here's the result. This is the mathematical prediction. This is the simulation. And well, they are pretty close. If I run this next time, I will get different numbers because you were using a random generator. So, but if I'm using, for example, 10 coupons, then the difference, there will be a difference. So the prediction, so we had to buy 35 boxes while the prediction was about 30 boxes. If I run it again, it says that I had to buy only 18 boxes while the prediction was almost twice greater. So it makes sense because the formula, the mathematical formula, was derived under assumption of large n, so it's kind of limit for large n, and it provides a good approximation for large n numbers, and it doesn't work well for small numbers. So finally, if we print our, so let's create so what I want to do now, I want to create a set. So we can create a set of numbers, and I will generate these numbers randomly. So I first should from I'm doing this in command line, that's why I import again random numbers. So I will create a list of random numbers. Let's say 120. Oh, okay. For range what? Oh, I should indicate from 0. Okay, so I created the set or from a list of random numbers. What is the length of my list? 120, because I'm using 4 for 120 times. What will be the length of set? So the list contains 120 elements, but the set has the length 78. Why it's the case? Yeah.
It's numbers that are produced twice aren't counted twice.
Or 3 times.
Yeah.
Or more. Yes. So because it didn't count the repeating values.
Yeah.
Yes. So the final comment about sets, be careful with iterating sets. So if I write for element in a set, you can iterate through sets, you can, but I will show you now what happens. Print element. So for now, you can see these unique elements in this set. And they look sorted. But as you remember, the set is an ordered data structure. So it has an order, but on the low level. So if I create more more numbers, like let's do 200. You will see that they're not in order anymore. They're not sorted. So you can iterate through a list, and you will know that on every next iteration, you will see a next element in the list. You can iterate through sets, but there is no guarantee that you will see these elements in some order. So, and this is the illustration. And I don't think you will need to iterate through sets because typically we iterate through something that has some ordering. Okay, so this is all about sets. Now we can do a break, maybe, or what do you prefer? We have to cover dictionaries and users' data structures. So 2 more data structures. It's a long day today. So what maybe we can let's do a short break, 5 minutes, and we will go to dictionaries. Okay. Do you have any questions about homework? Oh, Adam, did it work?
Number 7. Homer 7. I wasn't able to submit it. Me too. Like I'm not able to resubmit.
That's crazy.
I got.
Oh, so it's I understand it's you.
Yeah.
No, no.
Oh, this is oh.
Yeah.
So don't worry. So
Flashing.
crash.
It's
Right.
because
It was so scary.
Yes.
I hope he's a good friend.
Yeah.
I-
Of course I do that.
Yes.
Okay, no, it's fine, it's
But
just.
they spent to realize what was the problem.
That my grandfather.
Because it's something unexpected, unusual.
Yeah, no, that was weird.
I haven't gotten access to it. So it's just like. Spend it.
No. I'll tell you when you're gonna like swim in it, yeah.
Yeah, I'm gonna.
He's gonna like throw it in the air.
Yeah. I take all of it out. They. Oh,
I'm just trying to try to shut this right now.
no.
Gotta find a towel.
No. This is where that's. Just for now.
Let's
Gonna make.
If you land on red, you win.
Yeah,
Black,
I
you
know.
lose. Green, or whatever.
This is my egg.
Or you can pick numbers.
That's your.
If you win one number, 17.
Oh. That's not.
Well, we had to give him the food.
If you put in,
And we got into him, I just put makeup on it.
Yeah.
And then it lightly cracked up the makeup, but then it was on it, and I got that.
It is.
So. Thanks. Yeah.
Okay, so let's continue. The next data structure, data type is dictionaries. So the dictionaries we create or by dict and parentheses or by the empty curly braces. So dictionaries are useful data types because when you want to access not by number, not by just index, but by name, for example. So let's begin with a useful case for dictionaries. Let's say I want to create a dictionary of students. So, of course, I can create a list of students, but what if I want to access the information about student by ID, by the first part of your email, which contains and numbers and characters. So I want to access by a string. So in this case, we can use dictionaries. Like a dictionary. Or let's call this students, for example. Students. So I will just make up some IDs. And for a student, we can store some information. We can store one number, for example, GPA, or we can store a list like name, address, and so on. Name, address, and address, and sorry, is it accent address or address or address? Address. Okay. I just repeated and I wasn't sure if I. So some, I don't know, age, for example, you remember elements of list shouldn't be of the same type. Then we create another record, like another student. And again, we can these elements of the dictionary, they shouldn't be of the same time or type. Uh, for example, it can be just an integer. So, of course, it's better to have the same structure for students, but just to illustrate that you can use different values, I include just number here. Another field, also fields of the dictionary, we call these keys. They can be of different types. You can use an number, an integer for key value. Yes. You can use also dictionary of dictionaries, like the keys can be dictionaries. Oh, sorry. Yeah, they can, but typically the values are dictionaries. Like you can create a dictionary of students, and information of one student will be also a dictionary with fields, name, address, and so on. So we create a dictionary. Let's print it. And then we can access by the, for example, student ID. Instead of index, we can access by, for example, the ID. And then it will print the information which stored under this key. So, for example, in this week lab, you will create a dictionary, and the keys will be day 1, day 2, day 3. So you can create the keys of your dictionary, like day 1, day 2, just using the operations with strings, like they concatenate with str of the number. So you will create keys for your dictionary. And this is why the dictionaries are sometimes very useful. Like you can access by strings, not by indices to the elements. So dictionary has keys, the list of keys. Yep.
So, did you say dictionaries are better just for like readability?
Yes, for instance, you don't know how many I don't know, objects, students, or days, yeah, readability will you spend. And you can just, I actually didn't say how we create an element. So if you want to create a new element of the dictionary, you just type this key, for example, new one. Oh, sorry, it's print. I should create this before print. And um, it will create a new record in your dictionary. So you can add elements also um, um, by calling these names differently. I think about example. For example, In neural networks, we create two matrices, weights and biases, W and B. And for example, for one layer, you will create W1, B1. For another layer, you will create WB, W2, and B2. So you can do this very easily, just, for example, using this syntax, W plus str. And for example, there is iteration I or 1, and it will create a new variable which is called W1. So in your lab, you will create a dictionary of days. You don't know how many days will you have, but you will have dictionary with day 1, day 2, day 3 in the keys. So dictionary has keys. The keys are the indexes of our elements. They have values. Values is the list of the actually the stored elements of our uh, records in our dictionary. Yeah. Yes.
These need to be unique, right?
So if a good question, if I create a new a new record with the same key, like A736, what happens? It will rewrite your record. Yeah. So what else? Then we also can print end keys and values. This is method items. So items returns a list of tuples, and each tuple is the key and the value in this under this key. So also you can check if the element, let's say A763 is in your dictionary. Also, you can check if there is a non-existent element, and you will get an error. Oh, sorry. Oh. Okay. So when will you get an error? Oh, sorry. You will get an error if you want to access the element which doesn't exist. Like if I want to access an element by key which is not in our dictionary, you will get an error. So maybe first you want to check if this key is in your dictionary, and then you will access. Then you won't get an error. Okay. How to? Yep. This is a good question. So this is where the lambda function will be useful. So so you can't search, you can't sort by value. It's kind of the same as with tuples. If you want to do this by the second element of the tuple, or you can write your function, or you can use lambda function. So that's why I spent time at the beginning of class now. I want to show first how to remove elements, and then I will show how to sort or search by value because everything that we can do with dictionaries, like search, sort, it works only with keys. What? Oh, the problem is that my keys have different types. So actually, now I will show how to remove. Now we will remove this 67 records. Let's remove this record. You can use del and dictionary and 67. And after removing this element, it actually will sort our dictionary, but as you can see, it sorts by the key. Now, the question was, can we sort or search by value? And the answer is yes, we can. And this is actually why I introduced lambda function. Of course, we could do for and iterate for our dictionary, then somehow to map these entries into list of values, then sort the list of values, at the same time sorting the keys. So, but you can see that it's pretty long process. We will do this in one line. So, let's just modify our dictionary so that it contains only numbers. So, the first step, I will create the list of tuples. The list of tuples. Then, in the beginning of the lecture, we learned how to sort tuples by the second element. It will be exactly the same as sorting dictionary by values. But the first step is to cast this dictionary type into list type. Because if you apply sort to this data type, you will get an error that this data type doesn't have the sort method because it's not a list. It's a dict items. So first I will cast this into a list. Now we have a list, and a list has method sort. It's like in the fairy tale that there is. Huh?
What is dot item?
Items returns a list of end keys of tuples.
Okay.
The first element is the key, the second is the value of your
What
dictionary.
if there's three? Like, what if there's three? Oh, no, never mind.
Dictionary has only two. The tuple will contain only two elements, the key and the value. But of course, you can use like a nested dictionary here or nested list.
Yeah.
But like the upper level will contain only two parameters, index, key, and what we store under this index. So, so like in the fairy tales, there is an egg, and egg is in the bird or in the dark, and the dark is in the box, and so on. And somebody should find this. So the same as here. We have a dictionary. From dictionary, we create the list of tuples. Then we cast this list of tuples into list. list. Then we can apply to this list method sort. This method sort has parameter key. And finally, this is the egg. So the key we pass the lambda function. And in lambda function, we will sort by the second element of our tuple. So x of 1. And now I will get an error. And then we will begin our fairy tale again. So why did I get none? Why? Who can answer? why there is none? Huh? Oh,
With the dot slash.
no. No. So yeah. Yeah, it's funny if it's not on the exam. So you remember the sorted is a function and it's in place. So if our function in place, it returns none. So instead of print the function, I actually should print my original list because it's sorted in place. Okay. So each fairy tale has the nice end. So our code also will result in the sorted dictionary. I promise you. So, but we should create a separate variable. A separate variable. Oh, sorry. List. New new list. So wait a second. So we create a list of tuples. Then we will sort this list. So new list dot sort, and this list will be sorted in place. And only after that, I should print. So hopefully this time it will work. If not, we will start from the beginning. So print new list. Okay. Okay. It's a minor problem. Okay. So here is the original list, a dictionary, sorry. And here is the dictionary sorted by value. So that answers your question. If you want to get yeah. Okay, but it's not the end of our class. We have also to cover users' data types. So this was a list. Let's talk about complexity. Complexity. Mhm. So um, yes, again, the access to the elements of list by the key is constant time. Again, when we because so in this case we use the key as index in the list. if we access the element of list by index, it's constant time. Okay, so because sets are not so ordered, I mean they're ordered somehow on the low level, but not on the high level, we can't access elements of sets by index. As well, we can't use the last element of set because there's no last index. We can access dictionaries by index. So for example, if I want to remove element, but I can use del, but if I want to remove the value, I can use pop. So let's see. So for example, I can use print students dot pop. For example, somebody dropped the class, we can remove the student by index. Let's say A763, A763. It will remove the, I will print the dictionary. So pop removes the element, but at the same time, it returns its value. So it returns the value, but now you have only two elements in your dictionary. But in lists, you remember, in lists, pop without parameters works. It removes, what does it remove in lists? The last element. But in dictionaries, you will get an error. So you can't access the last element of your dictionary again because it stores the order is on the lower level. There is no like what is first, what is the last.
I don't understand that.
Huh?
What do you mean?
You overslept this.
What?
You overslept. Yeah. So we were talking about a little bit about hashing.
Oh, yeah.
So hash function somehow maps your element into the computer memory, but we don't know in which order it will actually store these elements. We will talk about hash functions in 2 weeks. There are two methods for hashing, and we will go through this in details. For now, it's just enough to understand that it creates some order, but on the lower level. Okay, yes. If you want to get the value, you remove, but you want to use the removed value somehow. Like in lists, for example, in list, we use this, for example, for searching, if the middle element, no, I don't think, no, not for search. I don't know. So if you want to remove element, but you want to use this value for some reason, like, I don't know, decrease the total sum or increase the total sum of remove. So the last data type for today, and actually for this class, we don't have other data. We don't cover other data types. Is users data types. So you can define your data type. Like here's the example. you can create the data type person, and here you can list the fields the variables that you want to store for this person. Let's maybe start talking first about what is a class. So even though we formally don't cover classes in this course, we don't cover lambda functions, we don't cover maps, but let's, because we covered the previous maps, filtering and lambda functions, let's cover also classes a little bit, at least just to understand how it works. But in the lab and in future classes, we will use only a specific type of classes. So class Python. So in Python, as you remember, maybe on the first lecture, so you don't remember, I said that in Python, everything is a class, an object. So now let's take a closer look. What does it mean, class? So in class, we can have two features, two different elements, functions and constants or variables. Like you remember, I changed the number pi in class math. So, for example, class string has a function sort. So we use our string, a string or my string dot sort. It will call a function from the class string.
Okay.
In math, we used math.py. It called the values stored in the constant pi in class math. Yes.
So like that's what it means by like inbuilt functions.
So
Like
yes, yes. So this function, you won't be able to access this function from outside of your class. It's kind of built in to the specific
class.
class. Yeah. Like as I said, strings, they have a lot of methods like sort, lower, upper, and many others. Every You remember the functions themselves, they have built in like underscore name, like hidden attributes. And when we print this, it prints the path for the name. Well, if we import the file, then it prints the path to these files and so on. So you can create your own classes. You can create a class, but when you create a class, you should initialize this class. You should write additional function in it. And I don't know why, but maybe because it's too complicated to write one extra function, they decided in this course to use the classes only with attributes, only with the classes without functions, without methods. So where is it? So if we use a decorator, this decorator will simplify the class. So you don't need to write init function here. It will do for you automatically. But you will be able to create only variables in this class. You can store just values. You can't use functions and methods. Does it make sense? So this is what the user data types mean. So let's create the coding problem for today. Oh, we almost don't have a time. Okay. But believe me, you will never use users data classes. I've never seen this in my practice. Never. Of course, we use classes, but not if we want to use some data structures, we use dictionaries or dictionary of dictionaries. But for this lab and next week, we will use these data classes. So the coding problem for today is called Girl Scout cookies. So Girl Scouts receive some orders from militaries, and this order contains information. Girl Scout order. So these orders contain the following information. The name, which doesn't look like the real name. Then the address, the price, the cost, was it paid or not, and the type of cookies and the number of boxes. So then after these lines, the next order begins, and so on. So we should create the list of orders, and finally we should calculate how many boxes of each cookie type was sold during this day. So we will do just the first part. We will create the list of orders, and I hope you will figure out how to calculate the total sum of boxes for each cookie type. You can just create a separate dictionary with cookie name will be the key, and you will just increase the number of boxes iterating through the orders. So, okay, let's write this code. Um, where's the cursor, the pointer? There is no pointer. Oh. Oh, there is still no point. I don't know what happened. But I don't see the pointer. Oh my gosh. Who remembers how to close the what is the shortcut for to close the window? Is it
Close the window. Control W.
huh?
Control
Control W? Oh, let's see. It doesn't work. I don't know what how to oh my god. Huh?
Yeah, okay, fine.
Control what?
I don't, it might be the first.
No, it's so I can use tab, so the tab works, but
Oh,
I don't see the. Oh, here it is. You help me. So, uh, can you see? No. So, yes, it came to my computer, and the mouse came back.
Thank you, but though.
I don't know. We can write another fairy tale. So today. Okay. So let's create a new file. A new file. Girl Scouts. So we need to import this decorator from data classes import data class. And then we use the decorator data class and we create a class. So instead of define a function, we use a class. So order. And this is the first time when we use uppercase characters, because as you remember, in Python, convention is that we use snake case, and only for classes we use camel case, camel style. So for example, we create a field name of type string, address of type string, price of the float. What else? Paid, unpaid, paid, unpaid of type Boolean, and finally the items. It will be a list of boxes. And now we can create the object of this class, order one. It will be order, and here we just place the values: name, address, price, paid, unpaid, false. Militaries don't pay usually for cookies. The the state pays. So then items. Let's use empty list, and then I can print this created order. And this is how it will look like. So this is the user data type. We created this type order. It's kind of dictionary. That's why I'm saying in practice, we use dictionary of orders. And the element of order will be a dictionary with these fields, name and so on. But here we're using the user data type with fixed fields. And for example, if you want to access to one field, like to the name, you can type order.name, order1.name. It will print the name of the person from the first order. Okay, I think we should stop here and take a quiz. So the idea is that we create a list of orders, and this will be our data set. So let's take a quiz and go to sleep. So okay, it's great. Yes, yet. Thank you. The mouse is working. So the password for quiz. Yes. Do you want to ask the password for quiz? I'm opening it.
What's your favorite Girl Scout cookie?
Oh, sorry. What's my favorite what?
What's your favorite Girl Scout cookie?
Gross.
Girl Scout cookie.
I don't remember what do they have in the assortment, but um when I was in your age, I believe my favorite was oatmeal cookie. Now I don't know. There is a large choice of cookies. So
My favorite is.
oh, actually, you can ask Nicholas. Nicholas likes sweets. I saw him today buying 2 pieces of cake. One was carrot cake and the other, I don't remember.
Professor, what's with such a good mood today?
It's just it's 9th week, so just 5 classes left.
Oh, yeah. Oh, you want to get rid of us that fast? Wow.
I'm kidding.
I love you. What the heck, man?
Well, I think we can celebrate. We covered all data types in Python today. Yeah. Mm.
Anybody? You want to buy a pizza? We can have a pizza party. Yeah. We'll all chip in $1.
Well, I believe with my salary, I can buy pizza to everyone. Of course, thank you for for your kind proposal, but
Say so.
Well, to be honest, when I was on the stipend in UOPAR as PhD student, yeah,
I'm smoking.
it was hard time, but working as a lecturer, as professor, it's so in UOPAR the stipend was free 30,000, and here the stipend is about 3 times more.
Buddy.
So I mean I understand how it's hard to be a student. When I was actually a student in Moscow, we didn't have light because the institute didn't have money to pay, and we were sitting in winter, and we didn't have heat, and we were sitting in heat in winter in Moscow, and you know the winters in Moscow, yeah, a little bit cooler than here, with coats. Yes. So I remember how it's to be a student. But it was just 1 year. I was studying when the Soviet Union collapsed, so that's why it was a really hard time. And we had the help from United States, like powder milk, the drumsticks, and it was real help.
Yeah.
And now we are going back to Soviet Union. It's crazy.
We both crashed out.
Okay, did you copy the password? Can I switch off the computer and go home? Okay. Well, actually, I shouldn't record this.